Okay, I'm going to write this in math terms. It makes a lot of sense to me, but it might not make a lot of sense to you, but don't worry, I will translate for you. Basically, if you were to divide polynomial by x minus c, and let's call this p of x, p for polynomial, and the remainder is p of c. And you might be going, hopefully you understand what that means, but let me translate this for you. Basically, I'm going to translate for you by example. If I want to find the remainder, I could do synthetic division, or what the remainder theorem says is that if I'm dividing by a linear binomial whose leading coefficient is 1, all I have to do is plug in the solution or the root of this into my function, and then it's going to pop out the remainder. So let's try with this one. Here's the polynomial. I know that k equals -8. So let's see what happens when we plug it in. -8 cubed plus 13 times -8 plus 46 times -8 plus 40. And I'm going to pull up my calculator, which, here we go. Oh, let's brighten that a little bit. You can't see it. Here we go. Okay. -8 cubed plus 13 times -8 squared plus 46 times -8 plus 40, -8. Look at that, just like before. So, either way you want to do it. If you want to use synthetic division, great. If you want to use remainder theorem, great. Like, both of them are meant to be faster than just long dividing. So, praise the heavens for that. There is something that I did forget to mention with synthetic division. This is really important. So when using synthetic division, always check missing exponents. And if there are missing exponents, we're going to use a placeholder. Here's an example of what I mean. X cubed minus 96x plus 34 divided by x plus 10. Okay, because what I want to remind you with synthetic division is that we were counting on the fact, let's bring up that page again. We were counting on the fact that we knew that our answer would be going down from our original polynomial. The degree, or each exponent, goes down by 1 every time. We need that. And so these coefficients were really important because that's saying, oh, this was our x cubed, x squared, x constant, like for this question. So if we don't have that in order, it's going to mess up our whole like multiplying, adding thing. And so what I mean by a placeholder is you see here how I have x cubed, I do not have x squared, I have x in my constant. Well, we're just going to substitute a 0x squared in there, and that's going to count as our placeholder. So now when I do synthetic division, I have 1x cubed, 0x squared, negative 96, and 34, and we'll divide by the negative 10. So that's something just really important. If you don't do that, it's going to mess you up so hard, you have no idea. X squared, so I get x squared minus 10x plus 4, and my remainder. Okay. So, sorry I forgot to mention that earlier, messed up our flow a little bit, but we shall recover. The last thing you're actually going to be asked to do for this lesson is to find all roots. Actually, we forgot to mention how to determine if a binomial is a factor. I take this back. We'll just go to the next page. Okay, so to determine if a binomial is a factor, think about it this way. Think about factor, factoring, where, let's say I have x plus 6 and x minus 2 would be the factored form of x squared plus 4x minus 12. Wow, that was impressive. Minus 12. Okay. So what I can say with this is that x plus 6 is a factor of x squared plus 4x minus 12, or x minus 2 is a factor of x squared plus 4x minus 12. That's what it means to be a factor, is that it divides evenly. So how could I check really quickly if something is a factor? Well, let's look at an example, of course. Let's see. Let's go into the fourth, minus 5n cubed minus 8n squared plus 21n minus 54 divided by n minus 6. And I want to know, is n minus 6 a factor of this hot mess right here? Remember, to be a factor, it divides evenly, which basically means we need a remainder of 0. Right, so how could I check? I could just plug it in, but the problem is, I mean, you could do that and that's fine, but further instructions on your homework at least say, if so, write as a product of two factors. This here is a product of two factors. Product meaning multiply, two factors meaning each of those is a factor. So I could plug it in to just see if it is, but if the answer is yes, I'm just going to need, well, what else does this need to multiply by? Meaning, we need to do synthetic division, honestly. Like, if the answer is yes, it's just going to be a whole lot easier if we do synthetic division. So, positive 6 outside, 1n to the fourth, negative 5, negative 8, 21, negative 54. Notice I went 4, 3, 2, 1, nothing, so we do not need a placeholder. So if this is a factor, I should get a remainder of 0. drop, multiply, add, multiply, add, multiply, add, multiply, add. Okay, so the answer is yes, it is a factor. So now to write it as a product of two factors, well, it's really n minus 6 times this stuff is going to give me that. So here's constant n squared, n cubed. So I know it is a factor. Product of two factors is n minus 6, meaning what I multiplied by, what I divided by, times what I got left over. N cubed plus n squared minus 2n plus 9. That is the product of two factors. If your answer is no, you do not have to write it as a product of two factors. You can just say no. So like I said, you can use the remainder theorem to check first and then do the synthetic division, or you can just do the synthetic division and check. It's really up to you. Okay, now our last thing is finding all roots. Okay. So let's say I want to do find all roots of x cubed minus 6x squared minus 61x plus 210. And I'm not just going to leave you in the dark on this because this is going to involve some skills that you're going to learn in secondary 3. But what I am going to do is give you this and say, hey, divide it by a binomial. I'm just going to tell you right now that every one of these that I give you is going to be a, linear. I forgot what I was saying. I'm sorry. Basically, this is going to work, I promise you, because you don't have the secondary 3 skills yet to do this. So, to find all roots for this, we need to start by determining if it's a factor. And we're going to use the synthetic division to do so. 3, 1x cubed minus 6x squared minus 61x plus 210. There's our remainder. So drop, multiply, add, multiply, add, multiply, add. Okay, so yes, x minus 3. So I know that one of my roots is positive 3 because I got a remainder of 0. So basically, I'm just going to keep track. Root meaning solution, so 3, because it was the opposite of that. Well, now I'm left with x squared minus 3x minus 70, and I have to find all roots of that. Oh, roots, aka solutions of a quadratic. Oh, that's something that you've done all year. If I just set this equal to 0, and now I'm just going to solve. So whether that be through factoring, complete the square, or quadratic formula. I always like to try factoring first. Is there anything that multiplies to negative 70 and adds to negative 3? How about negative 10 and 7? Okay, so x, because there's a is 1, I can go x minus 10, x plus 7. So now I have, from there, x is 10 and negative 7. So there we go. Those are all of my roots. The degree was 3, so by fundamental theorem of algebra, I should have 3 solutions anyway. So basically, moral of the story for this section is use synthetic division to get to a quadratic. And then you're going to solve by factoring or complete the square or quadratic formula. Okay. Feel free to email me if you have any questions, but I think that should be sufficient to get you through your assignment.